Okay, every engineer knows this feeling. You've spent weeks, maybe even months, glued to your bench designing the absolute perfect circuit. I mean, it is flawless. Every signal's clean, every function is crisp, you're ready to go. But then, it hits the real world, and everything falls apart.
So why? Why does that brilliant design suddenly crash and burn the second it's out in the wild, surrounded by all the other electronics we live with? Well, let's get right into it, because the answer is this invisible force that, honestly, most of us only think about when it's way, way too late.
And that answer is electromagnetic compatibility, or EMC for short. Look, my goal here today is to completely rewire how you think about circuit design. I promise you, by the end of this, you will never look at a schematic the same way again.
First things first, you need to understand that EMC isn't just one single thing. It's actually a delicate balance, a trade-off between two critical abilities that every single electronic device has to have.
Here's the textbook definition, and it's actually beautiful in its simplicity. EMC really just means your system has to do two things. One, it has to work properly in its environment. And two, it can't pollute that same environment with its own electrical mess. Basically, it has to be a good electromagnetic neighbor.
So let's think of EMC as a coin with two sides. On one side, you've got susceptibility. Just think of this as your device's vulnerability. How easily does it get knocked over by outside electrical noise? Then you flip the coin and you've got emission. This is your device's potential to be the bad guy, to be the source of all that noise that messes with other equipment. Every single product from a kid's toy to a data center has to deal with both.
Okay, now this is where it gets really clever. Have you ever wondered why agencies like the FCC are absolute sticklers for emissions, but they don't really regulate susceptibility? Well, it's because the free market takes care of it. If you buy a TV and the picture gets all fuzzy when your microwave is on, you're going to return that TV, right? The market just punishes bad products. But what if your new super blender makes great smoothies, but spews out so much noise that your neighbor can't watch TV? You probably don't care, but your neighbor sure does. And that's why governments have to step in and set emission limits to protect all of us.
And all of this brings every single engineer to a fork in the road. You really have to make a choice. There are two ways to handle EMC. And believe me, one path leads to elegant, profitable products, and the other leads to an absolute engineering nightmare.
Over on the left, you've got what's called the crisis approach. This is where you basically just stick your head in the sand, ignore EMC, finish your design, and then just cross your fingers and pray it passes the final test. Then, on the right, you've got the systems approach. This is where you're thinking about EMC from day one, from the very first sketch on the napkin, and you make it a core part of your design.
Let me tell you, that crisis approach almost always ends in disaster. And the fixes you have to make at that late stage, we call them band-aids. You're stuck adding bulky metal shields, slapping expensive filters onto the board, wrapping cables in ferrite beads. It's just ugly. And the penalties are huge. Wasted time, costly retesting, a product that's suddenly bigger and heavier, and worst of all, a delayed launch that can kill a product before it's even born.
But now, let's look at the other path, the systems approach. We know from experience that just by thinking about EMC from the very beginning, you can wipe out 90% or even more of your potential problems before you even get near a test lab. This isn't just, a better way to do things. It is the only professional and cost-effective way to design modern electronics. From now on, this is the approach you're going to use.
Okay, quick pause. If you're having one of those aha moments right now and this is starting to click, do us a quick favor and hit those like, share, and subscribe buttons for our channel Spectrum Speak. It really helps us keep making content just like this for you. Now, speaking of cost-effective, let's talk about the money. We need to put some real hard numbers to this, because EMC isn't some abstract technical problem you find on a schematic. No, it's one of the biggest business decisions you will make, whether you realize it or not. This, right here, is the golden rule of EMC economics. If you forget everything else from today, please burn this into your brain. The later you wait in the design process, the fewer options you have to fix a noise problem, and the more ridiculously expensive those few options become. So let's make this real. Early on, a fix might be as simple as moving a trace on a PCB. We're talking pennies. But what if you don't catch that problem until after production starts? Well, now you might have to add, say, a $5 custom metal shield to every single unit. Now multiply that by a production run of 1 million units. Yep, you just cost your company $5 million. And this graph, Wow, this graph tells the entire story in one picture. That top curve shows all the solutions you have available. See, you have tons of options at the beginning in the design phase, and then it just plummets. That bottom curve, that's the cost. It skyrockets over time. Your entire job as a designer is to solve EMC problems way over on the left side of this graph where it's easy and cheap.
Which brings us to the single most important takeaway. The one sentence you should have taped to your monitor. Electromagnetic compatibility must be designed into the product, not added onto it. It is not some feature you add at the end. It's as fundamental as the power supply.
So, I'll leave you with this final, crucial question. Now that you get the philosophy, what is the first, real, tangible step you're going to take on your next project to design EMC in from the start? Seriously, think about it. Because answering that question is what separates an elegant design from a costly Band-Aid nightmare. Thanks for watching. We're Spectrum Speak, and we're here to help you design for the real world.